Confidence intervals. We tend to use these when we don't know the population mean. And then we look for an interval where we are confident that the mean of the population lies if we know the mean of a sample of size n. Of course, we can always work out the mean of a sample. We assign a percentage to the confidence. Usually that's 90%, 95% or 99%. So what we're saying here is that we calculate the sample mean just here. And then, assuming a normal distribution, we can say that we are confident to a certain percentage that the population mean will lie within a range from, say, -k to k. So, if the area here is 0.9, that's a 90% confidence interval. Now, we know that the standard deviation of the sample of means gets smaller as n gets larger. So if we have a larger sample, we can be 90% confident with a smaller interval. This first example, we're not taking a sample or anything that we just discussed. It's just giving the idea of this interval in the middle. So we're told that the length of fish in a farm are normally distributed with a mean of 40 centimetres and a standard deviation of 5 centimetres. And if we look at part A, over what interval are 90% of the fish? So it's like having a 90% confidence interval here, except in this particular case we know the mean. We're looking for the lengths of fish, which are between here and here. So, note that it's symmetric. So we're after a value -k and k here for this interval. Now we can do this using an inverse normal CDF. Symmetric about the center, probability 0.9, sigma is 5, mu is 40, and that gives us 31.78. So that means 31.78 at the lower end, and then if we do 40, which was the mean, take away this last answer, and then add that last answer to 40, that's 48.22. So what we did there was we found that this one was 31.78, subtracted to find this distance here, and then added it on to 40 to find the value of k here. So now for 95% of the fish, so what we're looking at here is the same type of thing, but we want the mean surrounded by 95% of the fish instead. So we could actually just go back and edit this, because we had 0.9 there, and let's just change that to 0.95 and execute that. So that's 30.20. We're enclosing more of the fish, so therefore it's going to be a wider interval. We can see this value is lower. And then we do 40. I want to get rid of this. Bring this new value in here. And then we want this answer, add 40. It's done that automatically, so that's 49.80. And finally, for 99%, we can go back and let's just edit that to make it 99. Again, it's going to be wider, 27.12. And then we want to bring this value in here. And that should all update, and that will be 52.88. So the interval has to be wider if we want a greater proportion of the fish. And that's the same with the idea of the confidence interval. For the same value of n, we'll have wider intervals if we want to be more confident.